All right, good afternoon, everyone. My name is Brian Whedon. I'm the technical advisor with Secure World Foundation. We are a small NGO, and our main focus is long-term sustainability of space, which includes the topic we're going to talk about today, that being space traffic management. To warn those who maybe have been to this conference for the last few days, this might be more of a policy-focused discussion than some of the deeply technical content that have been in some of the other sessions. That's not to say that technology is not a huge part of this issue, but there's also another piece of it that I think we're going to focus on more today, which has to do with roles and responsibilities for different government agencies, some policy choices that the U.S. government needs to make, and kind of where the future direction of this issue is going to go. We're going to be holding today's discussion in more of a discussion format than perhaps some of the others. So there's not going to be structured presentations, but rather I'm going to guide the panel through a discussion of some of the major issues. And along the way, please encourage you all to submit your questions so that we can, inject those into the conversation. If you have not seen that before, the website to do so is AIAA.cnf.io, where you can submit questions of your own and also vote on questions submitted by others. So I'm going to start just with a quick introduction of our panelists. To my immediate left is Dr. George Neild. He currently serves as Associate Administrator for Commercial Space Transportation at the Federal Aviation Administration. He has over 30 years of aerospace experience with the Air Force, NASA, and in private industry, including prior experience as an Air Force flight test engineer, a professor at the U.S. Air Force Academy, and working with the Shuttle Mir program and the International Space Station. Next to him is Major General David Thompson. He's currently the Vice Commander of Air Force Space Command, Peterson Air Force Base in Colorado. He assists the Commander of Air Force Space Command, General Hyten, in organizing, training, equipping, and maintaining mission-ready space and cyberspace forces of 38,000 professionals across 138 locations. General Thompson's a career space officer with a background in propulsion and space launch, and also served a tour as Director of Space Forces in Southwest Asia. Next to him, we have Major General retired Jim Armour. He's currently the Staff Vice President for Washington Operations at Orbital ATK, where over the last several years he's been very instrumental in market development for small satellites and on-orbit satellite servicing. Prior to joining Orbital ATK, Jim had a 34-year career in the U.S. Air Force, including as Director of the GPS Joint Program Office and Director of Acquisitions for the Signals Intelligence at the National Reconnaissance Office. And last but definitely not least is Mr. Mark Daniels. He's currently the Vice President of New Technologies and Services for Intelsat General Corporation. Mr. Daniels has been working very hard to develop new technologies, to identify, develop, and refine new services and business models. He has 30 years of experience in engineering and operations within the satellite communications and aerospace industries. It's also applicable to today's conversation. Mr. Daniels is also the Executive Director of the Space Data Association, which is an organization that brings together satellite operators to share data on the location of their satellites to improve spaceflight safety. So to get the discussion started, I'd like to just kind of give a quick brief overview of what we are and are not going to be talking about today. Space traffic management is a term that a lot of people are familiar with, but it may be surprising to note that not a lot of people agree on what it means. It has a term with a lot of different definitions. Broadly put, for the purpose of today's conversation, I will define space traffic management as a governance framework for improving efficiency and safety of space activities. Now, what might be included in that? Well, we're talking about, practices and standards that satellite operators put in place. We're talking about national policy. We're talking about regulation. We're talking about international cooperation. All those are different tools that can be used to improve safety and efficiency on orbit. It's often very common to compare space traffic management to air traffic management. And while there are some parallels, I think there are also some big differences, and I think we might get into some of those as we go through the discussion. But space traffic management as a governance framework by itself is very much reliant on something else, which is information. And so there's a very closely related topic to space traffic management called space situation awareness. And while not, depending on how you define it, not explicitly part of STM, we're going to include it in today's discussion, in part because the policy discussions going on for where space traffic management is headed, a significant part of those policy does include discussion about where space situation awareness is headed. And space situation awareness is, generally defined as information about the space environment and activities in space. And that's the kind of data you need to be able to make management decisions. So to get started, I'm going to basically move the discussion through kind of three major stages. I'm going to start with a focus on kind of talking about what's being done now, I'll then talk about why there's this interest in changing things and moving towards more of a space traffic management regime. Then we're going to finish up by talking about what the near and midterm future might look like and some of the big changes coming down the pipeline. So I'd like to start, General Thompson, if you could kind of just give us a brief overview of what it is that's going on today with space situation awareness, because that's something the military is currently providing for the world, and it's something that you guys are doing a very good job of, I think.
Okay. Thanks, Brian. Ladies and gentlemen, thanks for coming and joining us today. I want to thank the AIAA for organizing the conference and this important discussion, and Brian for the work that he's done in advance to try and make us all look good. We'll see how that works here in about 40 or 90 minutes. And so, as Brian said, there are a lot of similarities and differences between space traffic management and space situational awareness, SSA. In fact, if you drew a Venn diagram of the functions and tasks associated with each, there would be a lot of overlap. I would say that, in a sense, that overlap isn't decreasing, but the roles of both are expanding such that there's more going on in each of the separate realms these days than there had been perhaps in the past. And really, space traffic management being a regulatory function and a means by which those that operate in a common environment or domain try to operate together in a predictable, reliable, safe, and secure manner, while space situational awareness, and certainly from our perspective, is more of a military function. And it has the aspects of what's in the domain and how do you operate safely in the domain and securely and in a predictable manner, but it also has what I'll call the additional aspects of a military function that says, what are the capabilities of the objects that are in the domain? How might they maneuver? What might they do? There's an element of intent with those objects and the operators, the owners and operators of those objects. What are the capabilities? How might they use them if, in fact, they may be a potential adversary? What sorts of behaviors might you see that are indicators of hostile or adverse actions to come? Predicting those in advance, responding to them, deterring some actions, but it is a much deeper understanding of what's in the domain, what the capabilities might be of those objects in the domain, how they might act, how they might affect your systems, and what you ought to do either in a deterrence fashion or in a responsive fashion or some sort of preventative fashion. So there's an overlap there, but there's also clearly a military aspect to that awareness that is in SSA, but not so much in space traffic management.
So what kind of capabilities is the U.S. military providing today for SSA?
Yeah. Okay. We do several things, and we've done them now for decades, because decades ago we recognized the need to do it for ourselves, and as the years have progressed, the importance and value of providing it with others. The first is a worldwide network of sensors to keep track of those objects in the domain, a whole host of sensors and various capabilities. We have a series of ground-based radars. There are multi-mission sensors that provide missile warning for both the U.S. and its allies. They have a function and ability to perform space situational awareness. We have a host of optical sensors, primarily used for deep space, geosynchronous orbit, and others, but we have a worldwide suite of optical sensors that we also use to surveil the domain, and then finally some on-orbit assets. Some of you may be aware of the Space-Based Situational Awareness Program and some other things that we use as well to track objects in the domain. And so as part of that, after you take all that data, we also generate, maintain, and update a catalog of the objects that are in the domain. And in fact, on the website spacetrack.org, available for organizations and individuals with an account, is a catalog of all those objects in the domain. So we provide that for the global community as well as performing conjunction assessment for all objects that we are tracking. Today we're tracking on the order of 20,000 objects, and so on a continuous basis, we perform a conjunction assessment of all objects against all objects to identify potential collisions, and then provide warning to owners, operators, and others that there may be a threat there, and in some cases, those operators give them advice and when they make decisions on whether or not to maneuver their spacecraft out of the way. So those are some of the things that we do today, as well as what I'll call event processing. Things break up on orbit, you have new launches that introduce new objects into the domain, and those sorts of things. When objects maneuver, it creates a new trajectory for the object that then once again you need to deconflict and run conjunction assessment on. So really what we do today is we have a series of sensors that collects all that information. We create and publish for all a catalog, and then do some of those special things that we need, but also for the benefit of others.
So Mark, as one of those operators who's on the receiving end of that, can you talk a little bit about what it's like to be able to get these warnings from the U.S. military that says, hey, by the way, in a few days your satellite might come really close to something else?
Well, we appreciate the ability that we now have as an industry to receive the JSPOC data. We didn't have that in the past. And in fact, that was one of the reasons why the Space Data Association was formed in the first place, so we could cooperate and share information between satellite operators and fly our satellites responsibly and safely. And so now that we're able to receive the JSPOC data routinely into our database, we're able to incorporate all the objects that we're allowed to have into our database and run conjunctions against those. So that gives us even a higher level of safety. And that includes debris, objects which we would not have otherwise. There would be no way for us to get that data right now, although there are some commercial sources available now for that. But the debris is important for us, and then we also receive conjunction notifications, CDMs, for government assets against commercial assets. And so now we can make sure that we're coordinated with military and government assets as well, even though we're not allowed to have the ephemeris of those satellites, obviously for good reasons, but we at least can do responsible operations, and so I think that's been a big improvement for space operations.
So when an operator gets one of these warnings, how do they react to it? Is it because the warning doesn't say you are definitely going to collide, right? It just kind of says there's a chance.
Right. So there's a back and forth that so we look at our database in the SDA to see what those conjunction assessments show, and then we compare that against what we receive from the JSPOC and those conjunction assessments, and then we look at, well, how close is it? Is it usually, if it's within if it's 60, 50 kilometers, we're looking at it, and we're looking at our next maneuvers, and we may just move up and maneuver so that we're not having to waste any fuel on a maneuver we don't need. Now, there are times when they get really close, and so if something that, gets down to, let's say, 5 kilometers, well then, that's where there's back and forth, and we go back to the JSPOC. They can do some higher level tracking for us and make sure that we're okay, and then we can decide how we handle that.
So that's, that's talking about kind of the physical environment around, which is this, the objects flying around space. But the SDA also deals with electromagnetic environment, correct? And radio frequency interference is also part of what
So the mission of SDA is to have safe flight operations in all the orbital regimes. So GEO, LEO, MEO, and then also the RF environment. And so we are focused on both.
So Dr. Neal, this was, we just talked just a bit about what is going on kind of for looking at objects and managing objects from a data perspective. Can you talk a little bit about, from a government oversight, regulatory perspective, what is the role of the regulator side of the government in what's going on today in space?
Sure, there's actually a number of different government organizations involved, and one of the motivations for that is the Outer Space Treaty, which many of you may be familiar with. It turns out that Article 6 of that treaty, which was drafted way back in 1966, and which now has over 100 different countries that have ratified it, and it states that the activities of non-governmental entities in outer space shall require authorization and continuing supervision by the appropriate state party to the treaty. So how do we do that today? And again, there are a number of different agencies involved. The FAA licenses commercial launches and reentries, but basically nothing in between. The FCC licenses radio broadcasts from space, such as for telecommunications satellites. NOAA licenses commercial remote sensing activities, things like taking pictures of the Earth. NASA and DoD are obviously major players in space, but they're not regulatory agencies, and they really have no desire to take on that role. So that's the current setup. What we're struggling with today is that we're starting to see some new and non-traditional ideas for activities in space. And as a result, there's been a lot of discussion inside the Beltway about it, whether our current regulatory process was designed to appropriately account for some of those new ideas. So we can talk about some of that as we go on.
So, well, that leads us into, so Jim, you and your company are one of the ones doing some of these new ideas. And specifically, you've got a concept for on-orbit satellite servicing that does challenge, I think, a little bit some of the existing ways we're both doing SSA and some of the regulatory. So could you talk a little bit about, how you guys are innovating?
Well, yeah, I'd be happy to. First of all, Brian, thanks for inviting me to be on this panel with, George Neal, a friend over many years, and doing some awesome work on the policy part of this. And I'm comfortable with Dave Thompson here, a now is Major General next to a has been. That didn't come out right. But anyway, I must tell you, I'm very nervous about being next to my first customer for on-orbit servicing, Intelsat General here. I know you're wearing your SDA hat, but I definitely don't want to annoy my first customer. And for those of you who don't know, the mission extension vehicle is basically a little backpack that will attach to a commercial ComSat at GEO and take over guidance, navigation, and control. I recently saw in the Economist magazine called it a mobility scooter for elderly spacecraft, which I thought captured it about right. As I mentioned, Intelsat is our first customer. We launch in late 2018, and I must show up to support the first Intelsat satellite in May of 2019. So I got a lot to do between then and now. We've been working this for over 5 years, first as ATK and now Orbital ATK. Had a lot of conversations with a lot of different government agencies that George was just talking about. But we've been basically successful. I found the U.S. government has been very forward-leaning on this and very positive. But I think it was part because of the business philosophy we took. We started out from the beginning with 3 rules, which was responsible, transparent, and cooperative. And on the responsible part, we wanted to make sure from the get-go, from our initial design, that we were going to be compliant with international COPE-US rules about debris, uncoordinated near approaches, RF transmissions that might disrupt the neighborhood, and use our most experienced people for manufacturing disciplines as well as operational management of the system. So we would be a responsible operator in the domain. Transparent, we wanted to work with all the regulators, whoever that might be, we didn't know, and make sure that we were transparent in what we were doing, how we were contracting it, how we were exchanging data, and especially the space situational awareness data with the JSPOC. And finally, cooperative, sharing data with our client to make sure our mission operations centers were in constant contact and that we knew the technical, operational, and mechanical and other interfaces on that. We also worked with the insurance companies and got that covered. So I'm coming to an answer here. It was as George just described. We had very good relationship with FAA, AST on our payload safety reviews. That went really well. We had a lot of help from NOAA for our remote sensing license. Yes, that's right. I had to file for a remote sensing license because we have rendezvous proximity operations cameras as we approach our client from the radial vector, and Earth is in the background, and we can see Earth, therefore I have to have a remote sensing license. Turns out that was a good thing because it allowed an interagency process that reviewed our data protection plan and other aspects, and it was a very healthy review, so good there. It wasn't until recently that we went to the FCC, and the conversation opened up really well, and then it got to the point where he said, yes, we're going to launch, and we're going to go into the disposal orbit and do testing. And there was a lot of words from the FCC after that, but it sort of boils down to, huh? And so, there was a lot of things, that if you were a basic ComSat, you would go up, you'd occupy a slot, a frequency, and you'd be that way for years. And maybe you change a little, later in the life of it. But we were talking about moving and changing and responding to emergencies. And, well, where are you going to be after the first year? Well, we don't know. We might be operating in the disposal belt, not in the GEO. How do you monitor the health of my MEV? Let's say I lose one of the remote sensors, and now so I would have to use different procedures for rendezvous proximity operations. There was really nobody that could tell us if we were doing the right thing or wrong thing. We were pretty confident, of course, but I wanted to make sure that we weren't at the last second going to be precluded from operating because of some international complaint. So overall, I'll say that the experience with the U.S. government has been positive, but there's a lot of unanswered questions yet, and I have to launch here in a little over 2 years, and I would really appreciate some clear answers before then. Thank you.
It's my understanding that, you guys were, very much pushing the envelope. Were you the first to get a remote sensing for on-orbit imaging of their space object? Is that?
I don't know.
If not, you were very close to the first.
Well, I think we were very close to the first on a number of aspects of that. I think we were the first, but I really can't say. I have to say the government also did a pretty good job of protecting our proprietary information, and I felt that they were probably protecting others' proprietary information as well, so I don't really know. But yes, we were treading new ground. That was apparent.
Well, and Dr. Neal is one of the people on the government side of this. I mean, this was probably, how was the government reaction to a company coming and saying, hey, we'd like to go do something that didn't fit into the kind of standard boxes you had predefined? Was it mass confusion, or was it a willingness to help? I mean, what was kind of the government thinking of that?
So it's challenging, but it's exciting. Remember, our office really has that twofold mission of ensuring public safety, but also, by congressional direction, to encourage, facilitate, and promote the industry. And so we were very pleased to see this type of innovative idea being put out there by industry, and wanted to see if we could figure out a way to make it work. And that's why we ended up having a lot of discussions in the interagency community. We already had this tool that Jim has referred to called a payload review, which is an optional activity that companies can come to the FAA and ask for, and it involves them telling, here's what we want to do, here's the kinds of things we want to try to accomplish during our mission and so forth. And then we will share that information with the other space-related agencies, including NASA and DOD and the intelligence community, State Department, FCC, Commerce, and so forth. And we have an opportunity for them to ask questions and to raise any issues and concerns. And that is golden in terms of feedback to the operator for early questions or issues that might drive their design, rather than waiting until the countdown is underway and then somebody standing up and saying, hey, you can't do that. So that's the idea. But again, this was a new and non-traditional type of activity, and so there were a lot of questions being raised about, gee, who is really responsible? Who makes the call on this? Is this required? Is this optional? Did they have to do this? What if they didn't? And it really has caused those of us in government to have to rethink the process that we have in place today.
So, Mark, as an operator, you know, there's the standard space environment problem, which is space weather, and you mentioned RFI, and we talked a little bit about these, you know, the collision warning messages you're getting from the JSPOC. But that's kind of all going on right now, but the space environment is going to be changing. In particular, we're seeing a lot more small satellites, CubeSats, mega constellations. Is that something that satellite operators are concerned about in terms of how that's all going to change things?
Yeah, Brian, it is. And I can speak for also my space data industry partners. So there's the Space Data Association. The 4 executive members are Intelsat and Eutelsat and SES and Inmarsat. And we do share a concern with the growing small satellite, you know, I guess maybe proliferation is sometimes the word we use. I hesitate to use it exactly like that, but because we're concerned about launching through, you know, low Earth orbit, and if the CubeSats and the small satellites, by the way, we applaud innovation, and we want to see that moving forward, and you know, we encourage that. We would just like to see it done in a responsible way. So there's deorbit mechanisms and lifetime restriction mechanisms, and you know, we don't have debris in low Earth orbit that you know, that's growing and not deorbiting on a timely basis, and so we know that that's going to continue, but we just like to see that done in a responsible manner.
Just to cite a couple of statistics, at the moment there are somewhere around 1,400, maybe a little bit more, functional active satellites in orbit around the Earth. And that's an increase of a few hundred from just, you know, 5 or 6, 7 years ago. There are, you know, depending on who you talk to, there are plans on the drawing board for between 3,000 and 11,000 additional satellites to be launched in the next 10 years. So that 11,000 number is from, you know, the estimates of people that have filed have made filings with the International Telecommunication Union that manages all the international spectrum that says, you know, hey, we would like to think about having a satellite constellation that's doing communications, and we need to file to give you a heads up that we want the spectrum. So that's kind of where the top end, the 11,000 number comes, and not all those might pan out. But the lower number, that 3,000, 3,500 or so, that is generally a fairly firm number of companies that have gotten investment, they've signed deals, they maybe in some cases started building satellites to go into constellations of hundreds to thousands. And that is going to create a whole new set of challenges to go along with all the potential benefits that would come out of such innovation.
Brian, I had one other thought that you just kind of spurred on is that we believe with the Space Data Association that it becomes a stronger capability and a safer operation for the space environment as members come on board. And so the small satellite community, you know, we are encouraging, and in fact we have a number of small satellite members already as part of the Space Data Association. And so we believe that can be one avenue for safer operations is to be a member of SDA and then, you know, share your orbital information, and we protect that, by the way. And so, you know, that's one avenue to, you know, there's probably multiple avenues that we need to pursue to have, you know, safe environment though.
So General Thompson, I mean, at the moment, you guys are the ones trying to track all this stuff and keep tabs on it. But there's also the other part of your mission, which is the national security mission. And there's changes there. So, you know, how is that kind of changing the way the Air Force is approaching this problem?
Yeah, thanks, Brian. You're right. The environment and the picture in which we operate and the environment we operate in space is changing dramatically. It was starkly demonstrated, you know, now, 9 years ago, in a couple of ways and several times since then. You know, I'm sure most of you are familiar with the Chinese test of their anti-satellite weapon back in 2007. They ended up destroying one of their obsolete weather satellites. And then in 2009, the collision between the Cosmos satellite and the Iridium satellite demonstrated two things in the domain. First of all, obviously the additional amount of debris and objects created as a result of those two events greatly increased what we needed to do to make sure we could operate safely, but also helped to spur recognition from us that we needed to share this data broadly so that others could avoid, help us avoid the same sorts of events happening unintentionally in the future. But especially with the Chinese and the work they've done since. Obviously now we have potential adversaries who recognize the importance of space to the United States and its allies in our national security and military missions, and therefore are increasingly developing and fielding capabilities to try and attempt to deny that capability that we get from space, if in fact we were to find ourselves in conflict. Well, as you know, the primary purpose the Armed Forces is for us to ensure that cannot occur and give our national leadership, our president, our allies options that ensure that they can meet the objectives they want to meet, and therefore we need to guarantee we can operate in space. And since we're also in a fiscal environment where we're not getting more budgets, we're not getting more people, what we increasingly have to look at is taking the people and the money we have today and repurposing that towards that SSA mission and the follow-on mission that says, if we understand an adversary has a capability and is going to attempt to use it against us in space, how do we protect and defend our space assets? How do we prevent them from destroying or damaging those capabilities? And so as we do that, it means the resources that we've spent in the past on SSA, but really to help others with respect to space traffic management. We're increasingly interested in not only doing some of that ourselves, but seeing who else can bring capabilities to the table so that we can all share the information and we can repurpose some of our resources to some of those more traditional military functions.
So does that include looking at some of our international allies and partners in terms of what they can?
Absolutely. In fact, through U.S. Strategic Command, I'm not a I'm not part of that organization anymore. I was until about 15 months ago. But from the allied partner perspective, we have a couple of initiatives. One they called the Combined Space Operations Initiative, that's specifically today focused on the United Kingdom, Canada, Australia, and New Zealand to expand our partnership in space, specifically and initially focused on space situational awareness. We are already looking and have conducted several exercises and I'll call them war games that have included others like the French and the Germans, and even the Japanese are interested. We've gotten some interest and are pursuing some things with the South Koreans, focused on not only them creating their own space situational awareness for their purposes, but also figuring out how to share all that information with each other so that we're not duplicating those missions and those functions, as well as both with commercial and other civil organizations, fostering the sharing of space situational awareness information so that together we're all safer, and we, the Air Force and the Department of Defense, don't have to focus as many of our resources on things like understanding conjunctions, helping sort that sort of thing out. So there's a lot of activity going on there to foster a sharing environment, and in fact figuring out ways to directly share data to increase the awareness of all of what's going on in the domain.
So Dr. Neal, so far we've focused pretty much on on-orbit activities, but there's another piece of space traffic management, which is what's going on in the suborbital market and some of the emerging concepts of tourism. Can you talk about what's going on there and kind of how that does or does not fit into what exists right now for the oversight framework?
I think we can, for the most part, treat them separately. The FAA does have a strategic initiative that is focused on trying to incorporate these new commercial space activities within the national airspace. And so there we have the traditional air traffic control functions, and they're concerned about rockets going up or going back down that might interfere with existing aviation traffic. So although it's one mission, maybe, that a rocket goes up to orbit and then may come back at some later time, we're really attempting to deal with that by breaking it into pieces, first working the piece within the national airspace, and then, of course, looking at what happens on orbit. Eventually, you'd like to see it all seamless, but again, based on the skills and the environment and the laws of physics that are involved, and we're trying to break things down and help them to be able to be worked on in a productive way.
So are there existing regulatory functions to cover the suborbital and that interface with the air traffic? Or is this another area of challenge?
So it certainly provided a challenge. The way we have traditionally handled space activities in the past was to have restricted airspace. And if there was a launch that was going to occur, then you draw a big circle around the launch pad. And if it's a 4-hour launch window, then you don't allow any of the regular aviation community to fly through that. And of course, if you're talking about launching from Cape Canaveral, there's all kinds of air traffic that wants to go up and down the East Coast. And so that can be a very significant impact to the airlines. And although they're a patriotic bunch and are happy to stand down when 4 or 5 times a year you have the space shuttle flying up into space, now that it's other companies that want to fly, and not just 4 or 5 times a year, but maybe every month or every week or even every day, then all of a sudden it's like, well, hey, wait a minute, how come we have to sit on the ground or burn extra gas to fly around that restricted area when it's just for another company? So those are some of the interesting debates that we've had to be involved in. Our approach to handle that really is to try to be very responsive, to try to automate a lot of this. In the past, it's been calling somebody up on the phone and typing in coordinates on the keyboard and sending a fax and so forth, and that is not the way you want to do business. So we're having a lot of progress being made right now in trying to automate this so that we can have basically real-time data from the space vehicles, and we can minimize the amount of space that is impacted and quickly release that space when the mission is over. And if something goes wrong, then we can respond in an appropriately short time frame. So those are the kinds of things we're looking at for the suborbital especially, but also for the orbital as they traverse the airspace either on the way up or the way down.
And some of those new space launch facilities might be in places like Texas and Oklahoma, which is even more disruptive to the air traffic than you know, Cape Canaveral, I think. Yeah.
That's true. Certainly, historically, our launch sites have been located on the coast because you want to fly out over the water, and if something goes wrong, then the person pushes the big red button and blows up the rocket so it doesn't fall on Disney World and so forth. But now we're talking about inland spaceports, right? And there are even spaceports that are co-located with major airports. We just recently granted a license to our 10th FAA licensed spaceport in Houston at Ellington Field. And of course, it's a major facility. You also have one at Midland International, and you have regular scheduled airline traffic there. So how are we going to handle that in terms of being able to allow all kinds of users of the airspace to operate with a minimum disruption?
So all these issues we've been talking about, you know, the potential huge growth in numbers of satellites. By the way, we didn't talk about it specifically, but there's also this space debris stuff flying around in orbit. I mentioned there's about 1,400 satellites on orbit that are functional. There's another 22,000 or so pieces of space debris bigger than a softball that are flying around right alongside all those functional satellites. And as you know, as our best estimates can say, there's somewhere around 500,000 additional pieces of space debris that are smaller than a softball that we know are there because they occasionally hit a satellite or damage a solar panel, or we do sampling surveys, but those aren't being tracked day to day. So as we talked about earlier, with all the maneuvers being done to try and do all the warnings done to do predicting collisions and moving out of the way, that's just for the big stuff. There's all the little stuff going on as well. So that is one of the drivers that's kind of that's forcing the U.S. government and satellite operators to think about what comes next. As General Thompson talked about, another driver is the contested space issue, where senior leadership in the U.S. military, General Hyten and others, have recently said, we the U.S. military need to start focusing on our national security mission, and potentially, look for someone else to help us out with this safety of spaceflight issue. Jim?
Yeah, I just want to put in a plug for commercial industry here. I mean, there's, the government definitely has its role and responsibility on this, and has a tendency to look at, buying a government system from a classic industrial partner. But there's a ton of energy going on, and with the proper policy or financial incentives, tax incentives, that could attack that multi-headed monster of debris, for example, or work space situational awareness. There are commercial vendors that are quite capable of doing that with a little bit of incentive. I know even in our mission extension vehicle world, we can't deal with the whole thing, obviously, but the big stuff drifting around in the geobelt, all we have to do is add a non-cooperative docking system, which a lot of companies know how to do, frankly. And we could take care of some of the big stuff, right? But right now, there's no policy or other incentives for us to do that. So that would be
Brian,
an approach I would recommend.
And if I can, let me add to that a little bit if I can. And General Armour is absolutely right. We recognize there is already significant and growing capability in the commercial market for a lot of this. For SSA, space situation awareness data and information, both from owner-operators themselves and from commercial and other companies and other organizations that are very much focused on that. It's one thing to recognize it and understand we need to leverage it or allow others to to help us out in this regard. What we're grappling with right now is how we, the government, can do that. And in fact, we have an analysis going on in Air Force Space Command right now. Some of you may be aware that for many years now, the SSA mission, the tasking of sensors, the generation of the catalog, all those things that we do today, event processing, have been done in the Joint Space Operations Center on the operations floor. And that's really a command and control center that is really an organizational level above where it should be. In fact, just a couple of months ago, we stood up a tactical unit called the 18th Space Control Squadron and have now decided that's a more appropriate level for this function to occur. And at the same time, have kicked off a mission analysis to try and understand it. As General Armour said, we know how to put military members, we know how to put government civilians, we know how to hire contractors to do these things for us. But what we don't know and what we're grappling with and asking for help and ideas and conversation is how we can continue to do what we need to do, but still try and take advantage of some of those commercial capabilities and understand an acquisition regime in which we can actually try and pursue those and to the benefit of not just us, but of all. And the focus there, as we had talked about earlier, is to take advantage of those capabilities, number one, some of which we don't have or some of which are more advanced than we have today. But the second piece is, if we can buy those services, if we can find somebody to help us with this mission and pay them to do it for us, that means we can have those military members focus on the military missions we've talked about previously.
Brian, I had one more comment on the same subject, so I wanted just to build on General Armour and General Thompson's comments there. So at the Space Data Association, we are receiving debris data from JSPOC, and you know, that goes down to a certain size, but we're aware that there's debris smaller than that. And we're right now seeking, there are commercial sources, as Jim just pointed out, to get smaller debris size from sensors that are available around the world, and they're commercially built into networks that process the data. It's reliable and it's accurate and it's repeatable, and both optical, passive RF, and radar. And so we know we can get down to commercially probably the 20 centimeter level, maybe even 10 centimeter level. And so that's one of our SDA goals, so that as commercial operators, we are addressing all of the debris that could be harmful to our satellites. And so, in fact, we have an RFP out right now that is seeking those data sources. So we're moving out on that.
So I'm going to shift the conversation here to start talking about some of what's being done to address some of these challenges. It's kind of where we're headed. I just want to remind everybody that if you have a question, the website address is up on the panel there. We have several here that I'm going to try to start working in the discussions as we go along, but please, if you have any others, please start adding them. So, General Thompson, you talked about bringing on board new sources of SSA data. Can you expand on that a bit and talk about what the military is doing to try and address the problem of how do we get more data, and what you're doing yourselves is what you're getting from others, sort of?
Sure. First, let's talk about, we'll talk about some of the things we're doing ourselves in the area of sensors. Some of you, I'm sure, are aware that we're in the process right now of building on one of the islands of the Kwajalein Atoll a new S-band radar that we call the Space Fence. Progress on that construction and that program is going well, and we expect it to be reach operational capability, at least an initial operational capability in fiscal year 2019. As Brian said earlier, today our standard and requirement is that we track all objects about with a radar cross section of say 10 square centimeters or larger, which is really a softball or the size of your fist. And as you all know, at this or orbital speeds, objects a lot smaller still pose a threat to many spacecraft. With this new radar, we will reliably track objects at least half that size, probably more, and expect a tenfold increase in the number of objects that we're going to be tracking. So anticipating perhaps as many as a catalog today that's about 20,000 objects, we expect maybe as large now as 200,000 or so objects, which is wonderful in terms of space flight safety, because it better informs the community in terms of what threats may be posed to the spacecraft they operate. On the other hand, I'm not sure yet we all understand, when you look at a conjunction assessment mission, whether that's the kind of data we really want to see or not, just because we may discover that much more often owner operators are going to have to make decisions about whether or not to move their spacecraft, where today, at some level, ignorance may be bliss. But accepting all of that data, running all of the conjunctions, as I said earlier, we today have tools and systems that routinely and consistently run conjunction assessment of 20,000 objects against 20,000 objects. Well, when that number is suddenly 2,000, that's a much larger data problem. And as we increasingly look and hope for allied sensor information to come in to get data from commercial owner operators and civil agencies, creating a platform and an environment and a set of tools to be able to do all that for us has been a challenge. We're working on that right now with what we call our JSPOC mission system, which really is to take tools and algorithms and hardware from the 1960s, 1970s, and 1980s and rehost it on modern IT equipment, but also update our algorithms, our tools, our processing capability to really move into this new environment so that we're capable without overwhelming analysts and having to hire an army of analysts to be able to do a lot of that in an automated sense. And so those are the, in addition to that, we're looking at the follow-on to some of our space-based capabilities, the space-based surveillance system we have today, as well as moving a couple of sensors from spots here in the Western Hemisphere down to Australia. Mechanically steered C-band radar that we used for years on the island of Antigua going to Australia, as well as the DARPA Space Surveillance Telescope that's down in New Mexico, moving that down to get some more coverage in specific areas of the world. So that's where we're going, but we're certainly anticipating an explosion in the information and the data, and expecting we are going to have to be able to deal with it and manage it and still do the mission that we need to do and provide some of that information to others that we have for years. And we recognize that as a challenge. We're looking for additional ways, as I discussed earlier, to make sure we tackle it in a responsible and timely fashion.
So Dr. Neal, there's been a lot of, as you mentioned, there's discussion in the interagency about this issue. There's also been some congressional action on it, not necessarily mandating what's going to change, but in terms of trying to understand the problem better. So can you talk about sort of where Congress has kind of been headed on some of these issues?
Yes. So last fall, Congress passed and the President signed the Commercial Space Launch Competitiveness Act, and that actually gave us a lot of homework. There were 12 commercial space-related reports that Congress gave out assignments on, and 6 of them we had the lead. Others were divvied up among the other parts of the government, but there are a couple that are very much applicable to what we're talking about today. Backing up, we mentioned the Outer Space Treaty and these new and non-traditional missions, and if we want to retain our leadership position in space internationally, I think most people would agree we're going to have to be perceived as following the requirements of the Outer Space Treaty. So who should be responsible for authorizing and continuously supervising some of these new and non-traditional missions? And that was one of the reports. The Office of Science and Technology Policy was asked, what do you see out there today and in the future in terms of these new missions, and what are your recommendations for how they should be treated and what authorities are needed and so forth. So there were a lot of discussions in the interagency community, and Dr. John Holdren, the director of OSTP, just signed out a report on April the 4th of this year and sent it to Congress that answered that question with the recommendation that the FAA basically leverage its payload review process that we already have in place for launches and reentries, and basically authorize through either a mission license or a mission authorization type of tool these new and non-traditional missions in space. And the idea is not to be burdensome to industry. It wouldn't be required if you're already getting a license from the FCC or from NOAA or whatever, but it's these new and different things that we're struggling. How do we deal with those? And so there was suggested legislative language included in that report, and now it's over to Congress. If White House and Congress can agree that this is the right way to go, then we can take this uncertainty off of our industry so they can continue to go off and do some new and innovative things. So that's one. The second one was a report that we were asked a very important question on, and that is it feasible for a civil agency to be able to process and release safety-related space situational awareness data consistent with our national security obligations? And again, a lot of discussions among all the stakeholders, and just last week, the Secretary of Transportation signed the report that responded to that question, and the answer was, yes, it is indeed feasible for a civil agency, such as the FAA, to take on this responsibility. So with that as the conclusion of the interagency community, including DOD and NASA and State Department, all the stakeholders there, we're ready now for a decision to be made by the administration and or the Congress to actually roll up our sleeves and talk about having the FAA take on the responsibility for the safety-related part of the mission that we've been talking about, so that the DoD could continue to focus on its national security challenges in space. And so we think that makes a lot of sense for those involved. We've been talking about this for a while, and I think we're ready to roll up our sleeves and partner with the DoD and the other stakeholders and see if we can make that actually work.
To put a commercial point on it, I mean, right now the FCC feels that they can authorize our mission. And so a lot of this other discussion about legal and administrative oversight is confusing to us, and it does add to the uncertainty in our business case, and we would like to have it resolved sooner rather than later. Pretty please.
And I can see that in the case of, for example, you guys are operating Earth orbit and you have to get out licensed FCC, but there are some other drivers we haven't talked about where, for example, there's companies that want to go land on the moon, and there's companies that want to go mine asteroids. And I think that those are cases where it is less clear the FCC should be the ones that have, the power to say yes to that and to authorize that, and kind of make more explicit that gap that you talked about. So the FAA or DOT in general taking over releasing some SSA data, that would be a big step, and that includes a lot of moving parts, right? Because there would probably be a change to authorization, and there's probably also a funding change. What are the prospects for those happening in the near term?
So we see three basic steps that need to be taken if White House and the Congress agree that this is the right way forward. We would like to have the authority then to process and release the safety-related space situational awareness data, just like DoD does today. We think it would be important to have immunity from lawsuits, just like DoD has today. And then finally, we'd need the resources to accomplish that. And that sounds sort of scary to think about that. Gosh, there's a lot of folks in the Air Force that are doing that job today, but they're doing a much bigger job. It's not just the safety. They're working a lot of different aspects of national security. So taking advantage of the lessons learned from the partners that we have at the JSPOC and in the military, bringing on some of the great new ideas from industry, new innovation, new technologies, starting with a clean sheet. We believe it is possible to do this job for a relatively modest cost, and to do so in a way that will be mutually beneficial. Once we achieve that transition, if you want to call it that, then I think it'll be a lot easier for the United States to have conversations about safety with the rest of the world, rather than asking the DOD to be in the middle of that. And there's always going to be some suspicion, some, gosh, are you telling us everything we need to know, and so forth. I think we're in a much better position to be able to talk about norms of behavior and standards and best practices from a safety perspective, rather than having it being filtered through the military. So they've done a great job so far, but now with the changes we're seeing, I think this would be a change that would be a real win-win.
And General Thomas, that's something that the DOD agrees with, and that last comment about, this helping to foster norms of behavior, is that something that the DOD would like to see happen?
Yeah, a couple of things I can, yes, and really the discussion of the three-step process or the three pieces. As you start thinking about it, thinking through it in detail, that third piece is really about the sharing of information, and just, the place we've been trying to go, obviously a non-military agency, another federal agency might be more effective and be able to explore opportunities and techniques that allow for the provision and the sharing and the fusion of all that data. Because when you think about, you think about those things that we have, the sensors and all the things that we need, not just for space situational awareness and the other multi-missions, it's not that those sensors need to go anywhere else than where they are today. It's simply that the data that we use today and then release broadly, we can now share with another federal agency, and their job is to take that information and do the things that we do today. And so certainly anxious and interested in pursuing this and seeing how that might work to let us get on to the other things. I'm sorry.
And the second part was, Dr. Neal mentioned that this might help foster international discussion norms of behavior in space. Is that something that also?
It is, and we absolutely, Mark talked a little bit about we want to continue to foster innovation with small sats, but we need some standards and norms of behavior in terms of especially, I think mostly, the licensing of what they're doing and what they're going to do at the end of life, but similar as you do in many, many other domains, establishing norms of behavior and how folks operate, and they can operate predictably, reliably, routinely, stably, is absolutely something we're interested in the Department of Defense. But at the end of the day, we also always need to say, as we do in other domains, there may be times and circumstances where we need to do what we need to do to protect the security of the United States and our allies, and that's always one of the caveats that we add. And it doesn't matter whether you're talking about operating in the air, operating in the seas, or in this case, operating in space.
And in fact, so one of the questions on here is, what aspects of the civil aviation traffic environment, and that's actually one of them, right? Because in the civil aviation world, the key air traffic regime applies to non-state aircraft, right? Which means that the state government military aircraft operate with what they call due regard, right? And so what you were talking about, sort of maybe a similar setup for space might be applicable, where the space traffic management is focused on the civil and commercial activities in space. Yes, and the military national security operates with due regard to that.
Right, and it is that we follow the regulations and the procedures in the National Air Traffic Safety System. Our U.S. Navy does the same thing when operating in in the global commons of the oceans and seas and navigable waterways, and they do that routinely, so that especially when you're talking about peacetime, the U.S. military can be counted on to operate in a safe, secure, and stable manner. And we would expect to do something similar in space. And then, as you all know, in those other domains, if you go into conflict, you still want to operate safely, but the rules change a little bit.
Yeah. So Jim, I'm going to come to you in a second, but I want to add another question to your pile. There's another question here that says, why not just use the internet model? People that may not be familiar, so the internet has a sort of a different governance framework, where there's a lot of it is based on technical standards that are hammered out by organizations such as the Internet Engineering Task Force and ICANN, and that kind of sets this way to undergird the operations of the internet. And there's a lot of kind of voluntary compliance with those, and industry plays a big role in that. So the question for Jim and whoever else wants to take it is, might that, how does that fit into this question of space traffic management, right? How much of this can be done by industry and kind of a voluntary standards way versus what role does the government have to play?
Well, let me start by saying that I think that industry best practices in the long run are going to evolve, right? But right now, we are where we are. We have, operating standards for space situational awareness and other operational standards that are just even available in industry. The Space Data Association is I think, part of that evolution to develop good best practices for that, and it will probably evolve into more operational standards as well. But the other thing I wanted to add was that, rules of the road and external operational management is one thing, but there's another part of air traffic, which is the safety of the vehicle itself. And, we haven't talked about, characterizing the health of a space system. Is it transmitting on the right spectrum? Is it under control? How much life does it have left? As part of space situational awareness, I think we want to characterize the health and status of that. But by the way, that's not a company position. That's sort of more on my side of the argument here. But there's a lot of work to do there, both with the policy level and with industry evolving standards. Did you want to add?
So I would like to add some additional industry viewpoints on the subject. So I think we believe that having a set of guidelines for on-orbit operations is important. And we applaud the efforts to move to FAA or a civil capability, and we want to help participate in that and give input in the process as well. I think we're interested in making sure that there's not undue regulations, that it's done in maybe industry best practices is one good way to think about how we're operating today. And there certainly are cases where industry best practices are not being used. And there have been some situations where objects in orbit are not coordinating with satellite operators like they should be. And that has created some, I think, potential hazardous situations, and there should be norms of behavior established for that, so that on an international community level, as well as satellite operator level, that we know how we're going to operate in orbit together with all the various operators. And so I think that's one important thing to establish. And then I believe that industry would like to make sure that the data sources are robust, that maybe consider commercial data sources for the objects. And the Space Situational Network is a fantastic network, and we use that today. And that may be part of the civil solution, but the commercial data sources are growing quickly. They're robust. They're very capable, and I would think that it would be an important thing to consider those commercial data sources as well.
Yeah, so let me just write on that a little bit. One of the areas that our mission extension vehicle is running into is rendezvous proximity operations, right? And there's a lot of precedent there, but we are setting precedent on, how close approach, how speed, how offset, et cetera, for that. And we do want to set good precedents for that for all the people. So that would fall into the operational best practices. But I also want to talk again about the health of the system. I mean, our customers, like Intelsat, very quickly demanded that our satellite be at least as reliable as theirs when we dock with them, right? And now that we've, started talking to the government as well, their standards for health and reliability of the satellite is pretty robust. And we have to add additional capabilities like cyber protection and things that we wouldn't normally have had on a commercial vehicle. So, I mean, there's a lot of room for growth in these standard interfaces, and both operationally and health of the system.
Also like to add, we have our satellites picked out, ready to go, Jim, so we're looking forward to you getting up there.
Waiting.
I was afraid you were going to say. No, we're in good shape, I think.
So Dr. Neal, would you agree that, there is a role for the industry to do the voluntary standards, but is there also a role for the government? I mean, or can it just be industry as it is in the case of, the internet?
So we're trying to look at this very objectively as a trade space, if you will, and you can envision a spectrum on one end. Maybe it's government-owned and government-controlled, and the government operates it, civil servant, and so forth, much the same way that the Air Force does today. On the other end, you could have basically a company that might be certified by the government to government standards to provide space situational awareness data. And then there's a wide range of options in between. My gut feel is that there's probably a sweet spot in the middle that recognizes there is an appropriate government role here, but we definitely want to be a learning organization, take data, take new technologies, incorporate inputs from academia and research to be able to refine and improve and enhance and evolve this system for the benefit of all, for improved safety and efficiency. So we want to be that type of a flexible organization and don't want to make all of those architecture decisions too early before we've had a chance to talk with all the stakeholders about what they can bring to the table and what makes sense.
So along those lines, returning to the question about, what is it from the air traffic world that we can kind of borrow for the space traffic world? In the air traffic world, there's a lot of direct control of aircraft, right? There are air traffic controllers actively in controlled airspace. Air traffic controllers are directly saying, you go here, you move there. That, to me, doesn't seem all that entirely applicable to space, given that most satellites aren't most space objects are not maneuverable under active control. But what about with human spaceflight? Might that be a case where there might be a little bit more of a case for more active involvement on behalf of a regulator?
Certainly the bar is going to be really high when we're talking about human spaceflight, and we're going to want to understand the data well and to have extra conservatism in terms of minimizing the chance of collisions. But I think really safety is good. We want to avoid collisions wherever they occur, and so that's going to inform our process there. There's certainly, again, different physics, different technologies involved, but maybe some lessons in terms of how to manage a large, complex, international regulatory system.
So you mentioned the word international, and there's a question that I've been waiting to ask for a while that came up, and that's, we've been focusing quite a bit so far on the U.S. national framework for this. But there's another question, which is how does that interface with or be part of an international framework for space traffic management? And so whoever would like to join in on that.
Well, all of my customers are international. I mean, so I'm already in the soup. We will operate all around the geo belt, and so landing rights or spectrum management is not only from the FCC, but it's from our clients. Filing with the ITU as well. So, I mean, we're already in that soup, and so any coherent policy would be welcome.
So this is clearly an international problem. You can't just focus only on what the U.S. does. At the same time, I think most people would recognize that trying to solve some of these challenging problems with a much larger group in the international community is going to make it take longer and be more complex. And so I guess my preference at this point in terms of how we can make progress is to try and get the U.S. act together first in terms of how we regulate our U.S. operators, but to be very transparent and open and sharing of our approach and our thinking and our logic and our rationale in the international community. And to the extent that we get it right, even if it takes a few tries to adjust along the way, then we would certainly invite others in the international community to come along and try to use that same approach. So perhaps like the GPS system can be a model where the U.S. can lead the way, and if we are open in its use, then I think people are happy to follow on and take advantage. Where we try to hide it and do it only ourselves, then we're going to spawn competition in other places. So those are some of the challenges we have to think about.
So I'm going to put on my European hat and give you the view from.
Wait a minute, you guys aren't in Europe anymore.
The space data members that are from Europe, and so there is a concern of flying satellites internationally, of relying on U.S. data. Now Intelsat, we consider ourselves a U.S. operator. All our satellites are licensed here, and we're headquartered here, and there is this Luxembourg thing too, but we're U.S. So we don't not necessarily share the same view, but there is a concern of relying on U.S. data, and is it always going to be there? And so if it's not, what do we do? And so therefore, we probably need an independent source of data. And then there's this question about, well, if the U.S. does it, we're going to have to do something in Europe too. So I just wanted to make sure you were aware that viewpoint is out there. And I don't think, I believe that our partners think it is the right move to get the U.S. to do it first. And then the European regulatory agencies will follow. And we'll probably have an independent, commercially available data source to make sure that we sort of have a capability that's there for us.
Can I add that, Brian? Yeah, and absolutely agree. Even today, we're trying to do a better job of taking advantage of commercial data and capabilities. One thing I think we ought to be careful of and make sure we don't go down this path, I won't tell you that there's necessarily evidence that we would, is regardless of the ultimate national and international regime and regulatory framework, I think we all need to agree that there's one catalog. That when you're talking about, the picture, the space picture, and you're dealing with conjunction assessment and what's going on here and there, is you want to have the reliable data, it needs to be authoritative, but we can't be we shouldn't be starting from a position of, well, my data says these are the conditions and the state of the object, and somebody else is arguing about that. And so while there's always somebody always has perhaps better information on the state or the status of an object, we have to make sure that you get it in, you get it updated, and so when you're dealing with whether it's conjunctions or orbital safety or other issues, we're all dealing with the same one reliable catalog.
Well, that does create a particular question of who manages that catalog, which I think is a very difficult question. Another one of the questions I want to tackle on here, we talked about earlier on about the issue of debris, and I hinted at debris mitigation. One of the questions is there a long-term plan for managing increasingly crowded orbits? And I kind of know what the answer is, but I would put that out to anybody else that wants to answer that question before I do.
Not a clue.
Yes, the answer is no, there is not a long-term plan. However, there are what I would say elements of a plan. So if you look at the history of our understanding of the space environment, in particular the space debris environment over time, it started in the 50s and 60s with initial exploration because we're going to be launching people into space as part of Apollo, so we got to figure out what that hazard is. And then that led to more knowledge, and then we started having spacecraft in orbit, and they started exploding, and people started saying, ooh, that's not good. And then that led to this issue of, well, why don't we need to minimize creation of debris? And so one of the big things that's being done is guidelines that operators use and been used in constructing satellites to minimize debris creation through space activities. But there's been more studies done in the late 2000s, early 2010s that essentially show that's not good enough. That even with full compliance with the debris mitigation guidelines, there's already enough debris on orbit that it's going to grow no matter what. So that has sparked a second discussion about should there be a need to remove some of that debris. So that's kind of the second pillar. It's not just minimizing the creation, but at some point, do we reduce or remove stuff that's already there? But there's a big debate going on about, is that we're going to remove the big stuff, or are we going to remove the little stuff? And what technology are we going to do for that, and who's going to pay for it, how much is it going to cost? That's a whole different complicated subject itself. Then I would say the third plan is what we're talking about today, which is kind of the space traffic management, reducing the impact on existing constellations, and that's sort of the third pillar of how to manage the space environment. This is, what I think is not there is, at least I haven't seen it, is kind of a coordinated strategy at either the national or even the international level of how to actually do all this. It's, what I just described is kind of what exists in the technical community that studies these issues, as far as, the challenges we need to get at. Trying to bring it up, another question here. Sorry, George, this is for you. One of the questions was, do you foresee a future where the FAA or the DOT or somebody else has an independent tracking network? Or do you think there are plenty of other data sources you can utilize?
I think we would want to be flexible and have a minimum set of architecture elements. And so, again, the DoD will always need to have their own sensors. We would hope to take advantage of the data that we receive from that, but we would like to build an open system that could accommodate other sources of data as well. Now, in an ideal world, that could be either commercial or academic or other folks that partner with or barter with us or somehow are part of that. It could be that we buy that extra data. I'm not sure we actually need to own and operate extra sensors, but if there's a particular hole, then I suppose in theory, then we could have a case for that as an exception.
So to add on to that, one thing we haven't talked about here is in the last 4 or 5, we've hinted at it, in the last 4 or 5 years, there's been a lot of growth in the commercial sector on SSA. And there are now multiple companies that are building and operating tracking networks and telescopes, and in some cases even radars, that are tracking a pretty good portion of what's in space. And as that technology matures and as those efforts mature, I think there's probably a pretty good chance that that will be a very good source of data going forward. So for the two commercial operators, there's a question here that effectively says, are there concerns that the U.S. moving first on this might kind of handicap U.S. industry? In other words, that by the U.S. government putting in place regulation, oversight, whatever, space traffic management, that would be a detriment to U.S. industry. Is that something you guys agree with, or do you, or we just disagree?
Well, we certainly, at least I certainly agree with the concern. I'm just not observing that at this point. What we're seeing as a company is that the U.S. government is sort of leaning forward, trying like crazy to get out of the way and let us go set positive precedents, not only in orbit, but, lunar exploration and some of the more exotic missions. There's a lot of schools of thought there. I mean, even in our ComStack discussion the other day, there was we will have no rules at all school of management out there. But I think some reasonable amount of regulations that are good precedent setting are on the way. And yeah, it's a concern, but I'm not observing anything that would let me think that they are going to be in the way at this point.
So if I could just push back on the premise a little bit. As we see this, it's a multi-phase process. The first phase is we're providing a service. We're providing data, which you can use if you like. If you find it helpful, great. If not, don't pay any attention to it. Second phase, if we're up and operating and people acknowledge that it's helpful and there's good data there and so forth, then that's when we want to be engaging with the stakeholders and trying to actually develop those norms, those standards of behavior, those best practices and guidelines when we have the tools and the data available to see what works and what helps and so forth. Way downstream, there could come a time where we want to have actually some requirements and some regulations, but we would want to do that in a way that doesn't penalize U.S. operators. So we want to make sure we have a level playing field, because again, we've got that other part of our mission: encourage, facilitate, promote. But at the same time, we want to recognize what things will help the safety aspect. So it's complex. That is not something that's going to come in right from the get-go in terms of, oh no, here's more regulations that's going to penalize U.S. companies. That is not the plan at all.
So I would agree with your points and applaud those points, and I agree with you too, Jim. We've had discussion in industry amongst our other fixed satellite operator kind of partners, and the concerns are there, but we think that we're going to be able to engage in dialogue and maybe help shape what's coming, and we do believe that we need some better maybe best practices is the best way to put it, or controls is maybe a little bit too strong right now, but some ways, rules of the road for how you conduct operations, certainly at GEO. Now, the LEO environment, maybe the same thing applies there too. But we want to engage and help the process along, and I think all of our companies are doing that to a certain extent, and we've been talking to Senator Bridenstine and providing input to the process. So we're encouraged by it, and we do like the idea of providing getting data as a source of information that we can use, and we also want to make sure that some of the activities that are going on right now on orbit have some mechanisms to, and I'm kind of talking around the subject right here just because of the sensitivity of it, but we need to have some mechanisms to deal with objects that don't coordinate.
So, General Thompson, there are a couple of questions here that I think fall into your ballpark. One of them is rather specific to Air Force Space Command, and it's in reference to the Astrodynamics Innovation Committee that I think was created a couple of years ago. Can you talk about what that is and kind of what the future for that might be?
I can. In fact, I think we have a member sitting out in the audience, but I won't call her out to answer the question. It is. A lot of the numerical tools, the standards that we've used in creating, maintaining the catalog and the associated activities, propagation associated with conjunction assessment, so on and so forth, we have used for years. We created this as a standard. We applied a very tight standard to the day that we accepted the processes that we would use in creating tracks in the catalog and maintaining it. But that was created and established in an environment of what I would call a sparse data environment. At the time it probably didn't feel that way. It certainly is today. And so the astrodynamic standards that we use today, the numerical methods that we use today in the Air Force really don't meet the standard and are not the most effective use of and way to accomplish our mission in the data-rich environment with especially a whole lot of additional organizations out there that can provide data in any number of forms. And so what the Astrodynamics Innovation Committee is doing is trying to help us work with academic institutions, industry partners, other civil agencies to really look at the environment that exists today, the type of information that's available, and how best to use all of it to the benefit of all to establish what is a high accuracy but up-to-date current state of information for all of these objects. And the approach we use today and the standards we use today and the methods we use today just simply aren't suited to that. And that's what the committee is trying to do, is help us understand and move forward in a manner that really allows us to use all of it.
Mm-hmm. So last question is to you, George, and that's there was a question that came out about, so what is the plan? Does DOT have a plan for if they got this authority from Congress, how they might move forward?
Well, we've been doing a lot of thinking, talking, brainstorming on exactly what this should look like. We're trying to be open-minded, objective, and not prematurely decide important aspects of the architecture and so forth. So we think a good way to get started might be to have a pilot program, if you will, that would allow us to practice transferring the data, protecting the national security information, doing the processing and distributing it and so forth, in parallel with the ongoing collision avoidance warning work that the JSPOC is currently doing today. And that will allow us to try some different things and to really get our hands dirty in terms of what the challenges are and what the promising way forward is. And then to the extent that there are remaining questions about cost or schedule or the accuracy of the data, we can address those. And if it's just not going to work, then we can pull the plug and say, well, we tried. And if it does, then that'll put us a ways ahead in terms of getting to our eventual capabilities. So I think that would be the way I would describe our general approach, is we're in the mode right now of touching base with all the stakeholders, making sure that we're all on the same page and have a good direction to head, making sure we have the necessary authorities and resources to do the job, and then hopefully start with a pilot program that would allow us to get started very quickly.
All right, thank you. Well, please join me in thanking our panelists for the discussion today.